Happy Technologies.
So, welcome everyone. Today's webinar on live cell images from Curiosis. My name is Oliver Deutsch. I'm Chief Business Development Officer at HB Technologies. We're based in Tübingen in Baden-Württemberg, Germany. Now, I'm your host for today. And before I hand over to Markus Rothe, who's the head of our instruments division, just a couple of housekeeping things. So we're planning for 1 hour for the live instrument and software demo, including the Q&A session at the end. If you have questions at any time, please just type them into the chat and we'll answer them at the end in this Q&A session. And as I said, we'll record this, but we won't record the Q&A session. Okay, so hands over to you, Markus, for the introduction of today's speaker.
Yeah, thanks, Oliver. So my name, as already said, is Markus Rothe. We are a distributor for the Cellogers, for the live cell imagers. And I'm happy that we have today here Kevin Chang, who's the product manager from Curiosis. And he will give an overview of the instruments. And I would say, Kevin, let's start.
All right. Thank you, Marcus. Hi, guys. My name is Kevin. I'm in charge of sales within the European territory here at Curiosis. And today I'm just going to give you guys a brief introduction about our company, the products that we have here for our live cell imaging devices. And briefly, also, I'm just going to run through the 4 live cell imaging devices that we have right now here at my desk, and also the software demo followed by the Q&A. So I'm just going to share my screen to give you that brief intro on the or let me just put that back. Great. So Curiosis, who we are, what we do. We're a life science instrument manufacturer based in South Korea. We've been along since back in 2015. So we don't have a very long background history within Curiosis, but we've been steadily expanding our products and our portfolio within the live cell imaging devices, and also for cell counting, including parts for consumables as well. So the main core technologies that we have here at Curiosis are sensor control, instrumentation, we have reliable hardware operation, microfabrication, we simplify preparation, and electronics precision software control system. Apart from our headquarters located here in Seoul, we also do have our very own factory located not too far away. And all of the hardware and software are manufactured, developed in-house. So all of our hardware, apart from the obvious for raw materials, we have all of our own modules. Even the optics and the boards are developed and trademarked by Curiosis, and we manufacture everything in-house. For the software as well, we do develop our own software from scratch. We don't source any sort of platform or other software technologies. We make everything here from Curiosis and out. For products, basically when you think of Curiosis, I want you to think about 3 different categories, and those are cell imaging, cell counters, and sites. We also have our digital optics, but this is more profound onto our separate division for digital optics. So every optic and optimization of all of our objective lens technology boards, everything are composed within Curiosis. And other than that, the product categories consume from the cell imaging, cell counters, and sites. So the first product I'm going to go through is the Celloger Mini Plus. We actually launched this product about 2 years ago after a Mark I product, which we call the Celloger Mini. And that used to be based on only bright field microscopy with the fixed 4x magnification. And from then on, we decided to expand and optimize our specification technology onto with the Celloger Mini Plus. Now, the biggest USP we have about the Celloger Mini Plus is that it has an objective lens located below the surface. So while you're operating the device inside the incubator with your cell assay, you can run through different positions, multi-positions all throughout. And the coolest part is you don't have to remove the device out from the device from the incubator. You can operate everything inside the incubator. So if you're running a cell assay for a few hours or a few days or a few weeks even, you can run time lapse ongoingly inside an incubator without having any crash downs. So for the Celloger Mini Plus, we actually specify the specifications for this product and most of our other products because we try to target most of our products within the low and middle tier of the market. So for example, the Celloger Mini Plus, including the other products, which I'm going to go through, the Celloger Nano Stack Pro, they're all based on bright field microscopy. But for the Celloger Mini Plus, you can add on a single color. So you can add on either GFP, a green fluorescent, or RFP, red fluorescent, onto the product. And for the magnification as well, you have a choice between either a 2x, a 4x, and a 10x. And either of the three options we have for the objective lens and for the colors, you have to choose either one of them. So I'm just gonna really fast just run through the products and then show you on screen with the actual products. For the Celloger Nano, it's specification-wise, we offer the same. So you have a choice whether you can choose only bright field or with green or red fluorescent. And for the magnification as well, you can choose either one of the three. It's a fixed, the objective lens are fixed upon ordering and manufacturing. But for the Celloger Nano, it's about half the size of the Celloger Mini Plus. And the main target, although the Celloger Nano can also operate inside an incubator, it's a single position product. So for the Celloger Nano, it's mostly used within a clean bench or as a countertop, benchtop live cell imaging device. And not sure if you can see here, but we have a control knob on the top for the X and Y, and also on the back, I'm going to show you later, we have another control knob to control the Z axis for the focus. And the Celloger Pro is actually one of our newest products that we launched about a few months ago. The Celloger Pro actually optimizes it incorporates in supplementing the Celloger Mini Plus. So for the Celloger Pro now, it comes with the standard bright field microscopy, but it has two colors at the same time. So as you can see on the pictures here, you could do your multi-color fluorescent imaging, capture images from multiple positions, which we also have for the Mini Plus. But for the Pro now, you have two colors, so it's a dual fluorescent live cell imaging device. And all of the other capabilities that we have on from the Celloger Mini Plus are also applied for the Celloger Pro. And for the Celloger Stack, it's actually based on only bright field microscopy, but the Celloger Stack is much bigger compared to the any of the other Celloger products that we have here. And the Celloger Stack is mainly targeted for the biopharm industry. So as you can see on the picture here, we have a Corning cell stack on the device. And most of the questions that we get from this is if the device then can visualize all 10 layers, and the answer is no. Unfortunately, there's no products out there in the market that can actually read all 10 different layers. So for the Celloger Stack, it reads only the bottom first layer, and with the LED light shooting down from and the objective lens showing from the bottom of the surface, it actually goes through all 9 layers and gives you a clear imaging on the first bottom layer. And it's mainly used for research, for industrial, and for medical. So as our product lineup, we have for the live cell imaging systems, we have the Celloger Nano. It's a single position product. For the Celloger Mini Plus, it's a multi-position, but you have to come up with either one color and one objective lens. And for the Celloger Pro, it's a dual fluorescent. And not to mention for the objective lens, for the Celloger Pro, it's interchangeable. You can interchange the objective lens manually for all 3 different objective lenses. And for the Celloger Stack is targeted for the applying a 10-layer cell stack. And we're not going to be covering the cell counting systems, but we also have a FastGoB and a Curic. They're both bright field based for mammalian cells from counting mammalian cells from between 5 to 60 microns. And for disposables as slides, we have our own exclusive 4-chamber disposable hemocytometer used for our FastGoB and for Curic, and a cell purity chip. So this is actually trademarked to say as a filterless filter. So it enriches a cell sample into a 20-fold. But if you want more information about the disposables or the cell counting systems, you can contact HB Instruments anytime, and I'll give you a intro later on that as well. So this is actually pretty much it, just running briefly through just to give you a clear idea about the products that we have here. And now I'm just going to switch off to the cam here. Right, so if you can see, these are the actual products that I have out, all 4 in different sizes. As you can see, the Celloger stack is pretty much big. It's recommended to use on a inside an incubator that goes at least 200 liters. And same goes for the Celloger Pro right next to it. It's a dual fluorescent with interchangeable magnifications. So if you can see here, I have the optics. These are also all developed and manufactured by Curiosis. And once you pull out the vessel holder, so both for the Celloger Pro and the Celloger Mini Plus that I have here, the vessel holders are compatible for one and each other. A well plate vessel holder comes by default in the original packaging, but for the other vessel holders, so for example, if you guys are working on Petri dishes, tea flasks, or even slides, we have different compatible vessel holders for those. So you can use it for the Celloger Mini Plus or either for the Celloger Pro. And inside we have the optics in here down there. So for the Celloger Pro, you can actually interchange between either a 2x, a 4x, and a 10x magnification. And for the Celloger Mini Plus, it comes with 1 magnification. What can you see? Oh, there you go. The optics down here, the LED light shooting down, and for the Celloger Nano, it's a pretty small. So for the Celloger Nano here, we have the control knob here on the side for the Z-axis to control the focus. But unless otherwise, you could also work everything on the software. And for the control knob here on the top is for the X and Y axis. So yeah, that's actually pretty much it. All 4 different products, different sizes, specifications, all the product colors, they come in matte black. So I'm just gonna turn back. So that was it for the actual products. And I'm gonna share my file again here. Okay. Oh. Right. So right now I'm gonna jump on to our last stage pretty quick, but for the software. So for all of our devices, not just the Celloger Mini Plus, but also for the Celloger Nano or Pro or Stack, the devices, each of the device comes in 2 different softwares. The first one is the scan software, and the second one is the analysis software. And basically what you do on the scan software is what you see on the screen right now. You preview, you live feed on your cell sample. You can choose from different weld plates from 6 all the way up to 384. For dishes, you can change into different, as I mentioned before, if you change the vessel holder for each, Then you can switch to 35 dual, 60 dual, or 90, 100. We also have for T-flasks. And if you're working on organ on a chip or other type of sites, then we have everything segmentized for these. And although the dimensions that we have for the well plate or dish or T-flask are pretty much worldwide standard, you can customize the dimensions if in any case you have a different type of dimension or the dimensions are offset from the ones that we provide on the software. So yes, for the software, I'm just gonna run through again really quickly with the scan software first. So once you open this up, everything is pretty much easy. Once you unbox the product, everything's just cable to cable. It's just a plug and play sort of device. So once everything's connected and you have the LAN cables connected onto your PC, you're gonna have a pop-up like this for the connection. So once you get this icon and you double click on it, you just get full connection with the device and your software. Right now I have a coded cell sample working on a 12-well plate. So I'm gonna move on to that. Right, so I'm not sure if you can see, but as I move along, just double clicking on each of the wells. And once you click on the either of the wells that you're working on, it just moves to the center of the well. And right now I'm clicking on the diagonal arrows located at the top here, which is moving around the z-axis to capture the focus. We do have an autofocus function on the scan software, but it won't do anything if you try autofocus on a complete blur image. So what you really have to do is just get to pretty much close to the focal plane and click on the autofocus to capture something more proficient, more sharp. Back on here to the icons on the top. If you click on this file button, you can capture a image of your live streaming cells. You can also digitally zoom in and out, but it's going to be a little blurry because it's only digital. We have measure bars here in case you want to measure down your cells. And you can't really see clear right now, but you could also change the preference options here. For the appearance of the measure ruler, you can change the colors if you want. You could change the fonts. But these are just preference options, so I'm just gonna run through. And also, once you measure your cells, you can also save each image and it'll capture all of the numeric positions that you've made on the image. You could delete everything. Right now, the imaging is based on bright field. If you wish to switch over to green fluorescent, which is put on this device right now, if you click on the tab down here for FL green, it'll switch over for green fluorescent. You can capture the position and it'll give you an index on the side for the X, Y axis and also the Z axis. And not to mention, for the Z-axis, since in some cases the contrast and focus may be a little bit different, you can set a different offset for each bright field and green or red fluorescent on the same position. And right now it's blurry, so once I set this up, 1 second. Right, so it's getting much more blurry. I'm just gonna go back. Right, once we get to something more clear, you could also adjust through the LAN power that we have down here, just in case, because initially, and as a background for all of our Celloger products, they're to be operated inside the incubator. mainly to be operated inside an incubator. So all the settings, all the default settings are based on 0 dark. So right now I have everything out and it's exposed to the room light. So I'm just going to change over the lamp power exposure. You could get a much more bright and clear image. Once you set off a different offset for your position, you could also change the offset that you have. And you could apply it, and it gives you a different offset based on the bright field z-axis. If you click on this button up here, which I skipped over before, it's for merging layers. If you click on that, it's going to give you a merged layer with the bright field and green fluorescent. And later, when you run time lapse, you could obtain both. So you have a choice of running time lapse and downloading images only on bright field, but also with green or red by choice. We also do have a fan here. Right now, I'm not sure if you could hear it, but it's on, now it's off. And the fan is actually just there. So as it operates inside the incubator, a lot of people are sometimes concerned if the device itself creates any heat or affects the humidity or temperature inside the incubator. And it really doesn't, because we use a very low voltage for the each and every one of the each and every device that we produce here. But just in case the device might be assumed to create any heat or humidity effect, you can turn on the fan to cool down the device or inside the temperature for the incubator. We do have another icon here. It's to turn off the status lamp. Not sure if you saw it before on the webcam for the devices. We have an LED light shining on top of the lamp, and if you turn this off, then the LED light will shut off, and you will have complete darkness inside the incubator. This button here, identify. If you click on this, the device, the LED light on top of the lamp will start blinking, because in most cases and for most of our users, they prefer using multiple devices inside one incubator. And in this case, you might get mixed up with which device is connected to which software, or which vessel is connected to which device. So it just gives you a blinking identification of where the device is and which device is being connected with the this current software. Back on to capturing positions. As I'm working on the 12 web plate, we have a few shortcut buttons here for current position, center of all wells, center of selected units, set matrix. So just one by one, if you move to a different position and you want to capture this position, you simply have to click on current position. It'll give you an index of where it is. Right, so right now it's on B4, so it gives you B4 X and Y axis with the Z axis for the focus. And if you click on center of all units, it'll just simply create one position in the center of each well. And this comes really handy later when you are working with either a 96 well plate or a 384. In this case, if you click on that, it will just simply create one of each instead of having to mark down every single well. In other cases, if you're working on a T-flash, for example, on a 75, it's hard to define where the center is and out. So in this case, you just simply click anywhere and it will just go to the center of 75. And you could also set matrix. And this option also follows up on our Celloger stack, because you're working on a 10-layer cell stack and has a wide field for the cell say. So if you do maybe 2x2 symmetric on a horizontal and vertical spacing of 10 mm each, generate, and it will create an exact coordinate both to the left, right, up and down, and filling up the blanks.
To
Yeah.
the listeners, just move the faces on the if Kevin is on the right side of the software, because you can just move the bar with the faces of the webinar. Okay.
Okay. Is it still showing? Oh, okay. This one, okay. There you go. Right. So I'm just gonna delete that. Move back to the well plate here. We're working on a 6 well plate, 12 well plate. You could also select different positions, like if you go here, you can click on that for current position. If you wish to go anywhere, not the center, and just anywhere out here, you could also use the arrows up and down and create the different steps. So I could do 1 mm. If I go down, it'll give a big jump. But unless otherwise, you could also hold down the control key on your keyboard and double click, and it'll move the purple dot for the coordinate. You can set up a new position. You could go here, set up another position, and all the key and functions are the same as your PC computer. So if you do that and you wish to copy and paste the exact same coordinates onto a different well, you simply have to click on this well, do Control C, it'll give you purple outline. Drag on the wells that you wish to paste. You do Control V, and it'll give you the exact same coordinates for each and every well that you've selected. Now, I'm also just gonna set up this one position. And in terms of setting up for the on the scan software, not just visualizing the live stream image of the your cells, before moving on to the time lapse section, which is going to be pretty much the end of the scan software, you also have 2 other preference options. So you can change just on basics, you can change your focus for the bright field and also green fluorescent, the offset. But you have different 2 other options here for Z stacking and stitching. So you can't do both at the same time. You just have to choose one, because eventually if you max out for Z stacking and stitching, it's going to be about 200 different images compressed into one file. So that's going to be a lot and hard to handle by any user. So right now you have to choose either Z stacking and stitching. Right now I'm just going to give you an example for Z stacking. If I enable for bright field, I could also do it for green if you want. I'm going to select both. For step, is set on default for 10 microns. The step is the distance between each image on the same position, just on different z-axis. For range, if I set down from -10 up to 10, it'll give you 10 images on the bottom from the reference position, 10 images up. So eventually, once you run time-lapse with this setting, it'll give you 21 images, 10 down, 10 up, and the reference position. And once you run time-lapse, it'll give you a compressed image file in which you could later process everything on our analysis software. And if you click apply it will give you the setting is confirmed on your index bar. If you go to a different position, set current position, go to that index. Also for stitching, if you could choose either only for bright field, you could also do it for FL green. The overlap, right now the default is set for 20% overlapping each other. You could also choose symmetric here, do a 2x2, and if you apply that, what it means is later on position number 2, once you run time lapse, it'll give you a compressed file of 5 to 5. So that's going to be 25 images. So it's going to be 2 on the left, on the right, up and down, and also filling up the blanks. So that's going to be 5 by 5, 25 compressed image files into one that you can process later onto your analysis software. And once you have all these settings done, we have a hidden tab here for time lapse. You could set up your scan location. You could enter your folder name. For total running time and interval, For example, if you wish to do it for 99 days, you could do so. With an interval of 10 minutes. With these two positions, it'll give you a total cycle of 14,256 cycles. So for the next 99 days, every 10 minutes, it'll take an image of each position number 1 and 2, right, for the next 99 days. And once you press start, it'll initiate. But also if you happen to be going away for the weekend or on holidays, and you know for sure that if you have the device on with the software and the PC on during time lapse, you could also set up a different date and time. So right now here is Tuesday here. It's like 5:32 here. So if I just wanted to start on Saturday, I could set it up for Saturday, set up a different time, start, then leave everything on, and it'll start exactly on Saturday on your designated time. So that's actually pretty much it for the scan software. Just to wrap it up, on the scan software is where you have full connection with the device and the software to preview and live stream your cell images. You can do various different types of functions that you have to sharpen your images, to also set up different presets for either Z-stacking or stitching. And you could also set up different positions depending on the type of vessels that you're working on. And once everything's set up, you can run time lapse and download all your images. And once you do that, it leads on to our analysis software, is where you re-upload the images to process, either for yellow masking and confluency. You could do you could check the mean intensity of each single position, or all the positions over time. You could make a time-lapse video clip. It also gives you a reference on the positions where those images were taken. You can make a time-lapse video clip for Z-stacking as well. And for stitching, you could create a complete image, not only just on bright field, but also either green or red or both. And once you have all these images processed on the analysis software, as soon as you click on the Analyze button, it'll also export all of your data on each image, time, confluency, intensity, etc., all the information that you need on raw data as on a CSV file. So in case if you guys are also using ImageJ or other softwares for processing your images, you can do so. And I think I forgot to mention, we also do have a separate software, is what we call an image converter. So what it does is, once you obtain all the images downloaded from our scan software, if you run them on our analysis software, it'll process everything perfectly fine. But in cases of using ImageJ, you need different formats for each image. So what the image converter program does is convert our images into the specific setting that you require to run off on your ImageJ. And since it takes a few minutes to download the images with the processed images, I'm just going to share some of the video clips that I made before. So this is on cell proliferation on bright field microscopy with RFP. Another example of cell proliferation. Here we have for cytotoxicity on GFP. Also on RP. And wound healing. So other than the information shared over the past 30-40 minutes, we have Also, a lot more information on our website at curiosis.com or on our YouTube channel. And unless otherwise, if you're looking for more information or to request for a more specific demo for each or any of the products specifically, you can contact HP Instruments anytime.
Okay, thank you very much, Kevin, for this overview on the live cell images. So for a person like me who hasn't worked in the lab for quite a while, my takeaway is you can basically take images of your cells while they're growing in the incubator without having to take them out there.
Right.
For data protection and privacy reasons, we have removed the Q&A session from the video.
Hope it was interesting for everyone. Have a good day, or maybe good evening to you, Kevin, to Korea.
Right. Yeah.
Thanks very much,
Just
Kevin.
getting off work now. All right.
Okay,
Thank you,
so
guys. Have a great
thank you,
day.
guys. Bye-bye, everyone.
And thank everybody for listening. Okay. Bye-bye.
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 Happy technologies.